Hello students, welcome to InGrade NEET JEE Foundation. In today's topic, we learn about some friction and the free body diagram. In the previous class, we have studied about the work, power, and the energy. Also, we have solved some problems related to the work. So the work is simply I defined if any object in a it is simply at a rest. Let's say the mass of the object is m. If we applied some force on it, let's say F, then there is some displacement, let's say S displacement, then the work done will be, just a minute, then the work done will be F dot S cos theta. In the previous class, I have explained that the work is a scalar quantity. Scalar quantity means we only take the magnitude part. In the vector quantity, we take magnitude as well as the direction part. In that class, the power I defined as W by T. I gave you a homework, that is the power we use to measure in a horsepower. So I gave you a homework that why there is a horse, why we are not using a elephant or any other kind of animal, and 1 horsepower equals to how many watts? Okay, and simply I defined the energy. The capacity of doing work is called energy. I have told you that we have two types of energy. One is the potential energy and another is a kinetic energy. Let's say this is the energy, one is a potential and one is a kinetic energy. What I told you that potential energy is because of the state of that body. If body is in a rest, then the body has potential energy because of its molecule. If body is in a motion, then because of that motion there is a kinetic energy. We simply called it then the formula of kinetic energy we have mv square. V square is simply the velocity of that object, m is the mass of that object. Okay. In today's lecture, I will tell you about some free body diagram. In previously, I have taught you about the motion, that the lecture will be uploaded in near soon. So the free body diagram will be, let's study about some free body diagram. Free body diagram. Why we are studying this? Because we have to solve the problem using free body diagram. Suppose I have a, let's say, surface, let's say this is the earth surface, then there is a mass m. Okay. Initially the mass is at rest. It means rest means velocity will be 0. Okay. The total weight of this mass will be mg. Then there is a reaction force because of that surface. Suppose a mass, because of that mass, a force is acting on that surface, then because of that surface, a reaction force applied by this surface on that mass. That is called action reaction force because of that Newton's third law. IIT में हूँ मैं, क्या पढ़ूँ सर, मैं पहले से IIT में हूँ. आप बेटा PYQs करो सिंपली. ओके, PYQs सॉल्व करो मेंस के. अभी मैं प्रॉब्लम सॉल्व करवाऊंगा और जो मैंने वर्क का किया उसे आप प्रॉब्लम सॉल्व करो, आपका उसी में सिंपल हो जाएगा. ऑलरेडी आपको IIT में चेंज करना है क्या? ठीक है. then the reaction force will be simply R. Now I told you in the classes of motion that in the because of the second law, Newton's law said that all forces in the world are balanced. It means the reaction force will be equal to the that mass of that body. R is simply mg. Because this is not in a motion. If the object is moving with the velocity of v, then there will be a acceleration. In next we have next free body diagram will be like this. Suppose this is the surface, mass of the body, let's say m. This body is moving with the acceleration a if we applied a force F. Because of that body, total weight will be mg, and the reaction force of that body by this surface will be, let's say, R. Okay. First we have to take the vertical component. Simply R equals to mg, because these forces are balanced force. If this force is more than this force, then this body will go up. Now we balance the force in the horizontal direction. If body is moving with the acceleration a, then the force will be F equals to simply m a. Okay, that is fine for you till now. Now we are taking the friction part. Let's say this is the body. Let's say mass of the body is simply m. Okay, total weight will be mg. If a body is moving with the acceleration a, let's say we are applying a force F. This time these two surfaces are not a smooth surface. It means friction is acting upon it. सर मैं आपसे पढ़ूं या रजवंत सर से? भाई ये आपकी चॉइस है, किससे पढ़ना चाहो, आपको जो अच्छा लगता है उनसे पढ़िए आप, ठीक है. If a body is moving in, let's say, x direction, the property of friction is, it means it's acting upon it in the backward direction. Friction is always opposes the motion. It means if body is moving in forward direction, then the friction is acting upon opposite to the motion. Motion in this direction, then friction will act in this direction. Okay, let's balance these forces. Let's say mass of the body is mg, then there will be a reaction force, let's say R. Okay, first we have to balance the vertical component. Okay, R will be simply mg. Now let's take the horizontal component. Okay, let's say because body is moving in, let's say, x direction, in this direction, it means that force is greater than the friction force. Then F minus F equals to simply m a. Because friction force is less and the applied force is greater than the friction force, body is moving in the forward direction. Okay, then a is the simply acceleration. Okay, till now what we have studied? First we have to study the free body diagram. Why we are doing this? Because we have to solve the problems. Okay, what we have studied, let's say mass of the body is simply mg. If there is a reaction force because of that force surface, because we have studied Newton's third law, action reaction force. If a body is applying mass mg on that surface, it means that surface also applying a equal and opposite force on that body. It means there is a reaction force, let's say R. Okay, simply R equals to simply mg. Because this time I am not taking that the body is in a motion. Let's say body is moving with a velocity v. This is a body of this is a body of a mass m, total weight will be mg. This time body with a moving with the acceleration a. If we applied any external force, let's say F, then what will be the reaction of that? First, we have to balance the vertical component. Let's say R will be the reaction force because of that surface. Okay. Then R will be simply mg. Now we have to balance the horizontal force. Simply F equals to ma. In the next example, I take the friction part. Let's say friction part will be acting upon this direction. It means that friction is always opposes the motion. It means if a body is moving in forward direction, then the friction will acting upon in the backward direction. Then the friction will be simply if we balance that force, what will be the equation of motion? Total. Body is moving in a forward direction. It means that this force is greater than the friction force. Simply F minus F, because these two forces are in opposite direction. Because F is acting upon in forward direction, friction force because of that surfaces is in the backward direction. Okay. Let's say M A. Okay. Now we take a plane at an inclined angle. Suppose this is a plane at an angle theta. Okay. Now we plot the free body diagram for this plane. Let's say this is the mass. This time we are not applying any external force. Mass of the body, let's say mg. Now we have two components. This angle also at theta, and this will be, if we have a mass mg acting upon downward direction, then we have a two component mg cos theta and mg sin theta. I hope you know that in the morning class I have teach you that if a vector like this, let's say A is the vector at an angle of theta, then the vector has two component, A cos theta or A sin theta. Okay. In the morning I have told you. So we have a two component, mg is acting in downward direction. We have a two component, mg cos theta and mg sin theta. Okay. The body is moving in this direction because of the mass of that body. We are not applying any external force. The body itself moving in downward direction. Let's say the acceleration of body is A. Okay, simple. And the reaction force because of that surface will be, let's say R. Okay. First we have to balance the vertical part. R will be simple, mg cos theta. Okay. Now we have to balance the vertical part. Sorry, horizontal part. mg sin theta equals to ma. This part. Because body is moving in downward direction with the acceleration of A, so we take the only, this is the vertical part and this is the horizontal part. What if we are taking the any external force applied on that body and body is moving this time in the upward direction, then what will be the equation of motion? Let's say this is the angle theta. Let's say our object is like this. Mass of the body is, let's say mg. We are applying any external force, let's say F, in this direction. Means the body is moving in upward direction with the acceleration of A. Okay. Then we have a two component like this. Theta will be the angle, mg cos theta and mg sin theta. Okay. Fine. Now, and there will be a reaction force because of that, because of these two body. This is the mass m and this is the surface. Because of that surface, there will be a reaction force. Let's say R will be the reaction force. Okay. Then first we have to take the vertical component. All forces are balanced in this direction. Then R will be simply mg cos theta. Okay. First we take the vertical component. Now let's take the horizontal component. If body is moving in the upward direction, means F is greater than mg sin theta, then F minus mg sin theta. If body is moving with the acceleration of a, then will be ma simply. Okay. This is the free body diagram of simplest body. Okay. I am teaching you in a very simplest way, so please remember this thing. Now let's take another problem. If we take the friction into this account, let's say this is a plane at an angle of theta. Mass of the body simply mg. Okay. Because of that surface, there will be a friction. If the external force we applied in this direction, friction force will be in this direction. Because friction always opposes the motion, so friction always acting upon opposite to the motion. If body is moving in upward direction, then friction will acting in the downward direction. Let's say this is the mg cos theta. And this will be mg sin theta. Okay, and R will be the reaction force. Then the reaction force will be R equals to mg cos theta. Because the body is moving in forward direction with the acceleration of a, then the net force will be F, because moving in upward direction, F minus F. Friction force and mg sin theta are in the same direction, then minus mg sin theta. Equals to m a. Okay. This will be the equation of motion this time, when body is moving in forward direction. Now let's study the friction part. First we have studied the basic of friction. Let's study the friction. Friction. Simply, first question we have arises that what is friction? Friction is basically opposes the motion. If body is moving in forward direction, then friction is acting upon in the downward direction. We have two kind of friction, that is the static friction and kinetic friction. Let's say a body of mass m. Okay. It is moving in this forward direction. Then the friction is acting upon it in backward direction. Friction always opposes the motion. Okay. Also we have two kind of friction. One is static friction. Another one is a dynamic friction. Okay. Means if a body is in a rest, this time body is not moving. We are not applying any external force. It means body is in a rest. This time means static friction is applying on it. Okay. How we denote it? Simply Fs. The static friction is directly proportional to the reaction force. Because of that surface, a reaction force acting upon this body, that is simply R. Okay, and R will be equal to the that mass of that body equals to mg. Okay, if we take the equal to sign, we have to put the any coefficient, that is R. Mu s will be the coefficient of static friction. Okay, or limiting friction. It means we limit the body to move. We do not want to move the body, so we called it static friction as well as the limiting friction. Limiting friction means it limits the motion of body. I will teach you this thing is in a graph. Let me first tell you about the dynamic friction. What is dynamic friction? If body is moving with a velocity of v, let's say this is a body of mass m, total weight will be mg. Okay, if an external force applied on it, let's say F, then there will be a friction, let's say in a backward direction. Because of that motion, a friction will be acting upon it. Because of that motion, a friction will be acting upon it. We call it a dynamic friction or kinetic friction simply. How we denote it? Simply Fk. This kinetic friction or dynamic friction equals to the simply proportional to the reaction force. Reaction force of the body will be equal to the mass of that body. Okay. Then if you put the equal to sign, Fk will be mu k R. R will be a reaction force and mu k will be a static coefficient of dynamic or kinetic friction. Both formulas are same for static and dynamic friction. The only thing is we have changed the coefficient value. The coefficient will be different. Coefficient is a constant quantity. It will be different for different masses. Because R we simply call it R equals to mg. So R will be different, mg will be different. Because R equals to mg. If we are changing the mass, then we are changing the reaction force. Okay. Now this topic is studied with the graph. Suppose we have a graph like this. The static friction and we have a kinetic friction. Okay. If we are applying any force on a body, it will not move till the external force will be greater than the static friction. Let's say a mass, a body having a mass, let's say m, capital M, body in a rest, body is not moving. Then static friction applying on it, small fs. Okay. If we apply an external force, the fs is still greater than external force. Means the static friction is greater than the external force, then the body will not move. Okay. If static friction nearly equal to the external force, body still will not move. Okay. If we apply any external force will be greater than the static friction, then the body will start move this time. Then then static friction changes to the dynamic friction, that is a kinetic friction. Okay. Till now, we are applying any external force, body is not moving. Okay. Because the external force is nearly equal to the static friction, body will not move. If any external force greater than static friction, then body starts move. In this part, body starts move, means the friction force start decreasing in this time. Okay. In this portion, the friction starts decreasing, and the coefficient of static friction changes to the dynamic friction. This part is the dynamic friction part, and this part is the static friction part. Okay. Now let's understand again. What I have teach you, we have a two type of friction. First we have a static friction or limiting friction. And next we have a dynamic friction or kinetic friction. Okay. Static friction means when body is in a rest, it means a friction is acting upon it, that is called static friction. Let's say this is a body of mass m. Let's say total weight will be mg. Body this time is not moving. It means velocity will be 0. A friction is acting upon it, that is called simply Fs. It is called static friction. Static friction simply equals to the mu s r. R will be a reaction force and mu s will be a coefficient of static friction, and R is a reaction force. Let's say R equals to mg, then mu Fs will be the mu s mg. Okay. Now let's study the dynamic friction. If body is moving with the acceleration of a, let's say body of mass m, let's say mg. Body is moving with the acceleration of a. Okay. Let's say force is acting upon in this direction. Then friction always opposes the motion. Okay. Then what kind of friction is this? This is a dynamic friction. Fk will be mu k r. R will be a reaction force and mu k will be a coefficient of dynamic friction. Okay. Now let's solve a problem. This is a problem. A body of a boy of mass m 4 kg, boy का mass है 4 kg. Okay, is standing on a piece of wood. He is standing on a piece of wood, having a mass 5 kg. It means the body of this wood is 5 kg mass. The coefficient of friction between the wood and the floor means in this part will be mu will be 0.5. That the maximum force that the boy can exert on a rope so that piece of wood does not move. यहाँ पे does not move means. Now let's plot first the free body diagram of a boy. Means the boy pulls the rope, let's say x force, the tension acting upon in this direction. Okay, the maximum force that boy can exert on a rope so that the piece of wood does not move. Okay. Now first we have to plot the free body diagram of a boy. Let's say this is a boy. because this boy holding a wire means tension is acting upon it, T. Okay, the mass of that boy will be mg. Because of the mass of boy, a reaction force by this block will be, let's say, N is acting upon in this direction because of that wood block. Then the equation will be, let's balance the forces, T plus N equals to simply mg. Okay, mass we have given boy, how much we have, 4 kg, and g will be 10 meter per second square, let's say 4 into 10, simply T plus N equals to 40. Okay, now let's plot the free body diagram for wood. Mass of the wood will be, let's say, capital M. This is the reaction force of wood. Boy also acting, boy's weight, because of that boy, a reaction force acting upon his downward direction, let's say N. Okay, and because of that surface, a reaction force R will be acting upon it, let's say R. Now let's balance these forces. R equals to N plus M G. Okay, what will be the mass of block? It is a 5 kg. Yeah, it is a 5 kg. Then R will be N plus 50. 50. 5 is the mass of wood block and 10 will be the gravitational acceleration. Okay. One more free body diagram. In the horizontal part. This time we balance the vertical part. Now the horizontal part of wood block and the surface of that surface. Because tension is acting upon in this direction, a friction is acting upon in this direction. Friction always opposes the motion. Then T will be simply the friction part. I have teach you earlier that friction will be simply mu R, and R will be the reaction force we have like this. Put the value of R in this equation, mu N plus 50. Okay. Then what will be the value of mu? Mu will be 0.5. N plus 50. Okay. Now we have two equations, T plus N equals to 40 and T equals to 0.5 and 50. Now put the value of N in terms of T, let's say. Now let's solve it. T plus N equals to 40 and T plus 0.5 N minus ka, let's put the minus sign, equals to 25. Now let's solve the equation. Suppose we subtract this equation, minus plus minus, then we will get T will be cancelled out, we will get 1.5, N will be equals to 15. Then the reaction force will be 30 Newton. This is the answer. Let's read the question again. G will be 10 meter per second square. Suppose a boy of mass 4 kg is standing on a piece of wood. It is a boy of mass 4 kg is standing on a piece of wood. Okay. Mass of wood will be 5 kg. Coefficient of friction between the wood and the floor will be coefficient of friction between this floor and this block will be mu will be 0.5. The maximum force that boy can exert on a rope so that piece of wood does not move. Means if a boy pulls that wire, let's say of a tension T, then because of that pulling, a force is exerted by that boy on that wooden block, let's say capital N. So we have to find the value of that N value because of that pulling by the boy. So what we have done, suppose we have plot first the free body diagram of boy. This is the boy. Boy is holding a wire, means tension is acting upon it. Simply a T in upward direction. Because boy is pulling that wire, it means a reaction force because of that mass applying on that wooden block will be N. Because of that mass of boy, a reaction force between the block and the boy will be N. N will be the reaction force between the boy and the block. Let's say it is acting upon in forward direction. Mass of the boy will be, let's say, mg. Because no horizontal force acting upon it, then we have to balance the vertical component only. T plus N equals to mg. Okay. Mass of the boy will be 4 kg. T plus N equals to 40 Newton, simply because tension is a force and reaction force also a force. Now let's plot free body diagram for wooden block. This is the wooden block. Let's say mass capital Mg. Because of that surface, a reaction force R will be acting upon it. Let's say capital R. Because of boy's mass, a reaction force N because of that block, and boys also pressurizing the wooden block with a reaction called N. This N is the reaction force between the boy and the block. This R is the reaction force between the floor and the wooden block. Okay, now balance the equation. R, because N and mg are in same direction, plus mg. Okay, then R will be simply R minus N. Let's solve this. R equals to simply N plus 50. Because mass of the wooden block is 5 kg and G is the 10 meter per second square. Now we have to balance the forces in the horizontal component. If mass, let's say mg is the mass of wooden block, tension is acting upon in this direction because wire is attached to it. Because wooden blocks want to move, but a friction force is acting upon it, let's say small f, because coefficient of friction is already given, it means then there is a friction force, then the first surface is not smooth. If they write the surface is smooth, it means that there is no friction is acting upon it. Okay. It is already given that there is a coefficient between the floor and the wooden block, that is the friction coefficient. Then T will be simply small f, that is the friction force. I have teach you earlier that friction force will be equal to the coefficient of friction and the reaction force. Okay. Then T will be simply mu, and put the value of R, let's say n plus 50. Okay. Put the value of mu, that is 0.5, n plus 50. Okay. Now we have two equations in terms of T and N. This is the equation number 1 and this is the equation number 2. Now let's solve it. T equals to simply 0.5 n plus 25. If you multiply 0.5 to 20 into 50, then it will get 25. And we have a equation like T plus n equals to 40. Solve this equation. T plus T minus 0.5, n will be 25. Now subtract this equation, minus, plus and minus. We will get simply 1.5 equals to 1.5 n equals to 15. Then n will be a 30 Newton. Okay. That will be the force that is applying by the boy on the wooden block, minimum maximum force applied by the boy. This will be the maximum force that the boy can exert on the rope so that piece of wood does not move. Okay. Now let's solve another problem. This is the problem. Okay. A block of mass m slides along the floor while a force, this is the force acting upon in this direction, let's say theta angle, as shown in the figure. Coefficient of kinetic friction will be mu k. Block's acceleration will be a. Now first we have to plot the free body diagram. This is the mass of a body. Force is acting upon in this direction on theta angle. So we have a two component, f cos theta and f sin theta. Okay. This mass is on a floor. Then we have a reaction force also, let's say R, because of that surface. Mass of the body will be, let's say mg, and a friction force acting upon in this direction because whole body is moving in forward direction. Okay. Now first we have to balance the vertical part. R and F are in the same direction, so I can write simply R plus F sin theta equals to mg. Okay. Now we have to balance the horizontal part. F cos theta, because body is moving in this direction, means F cos theta is greater than the friction force, minus F, because F cos theta and F are in opposite direction, so I have to put the minus sign. If body is moving in a acceleration a, then m dot a. Okay. If it is a dynamic friction, it is given already, Fk equal to mu k R. R will be a reaction force and mu k will be a coefficient of kinetic friction. Put the value of R in Fk, mu k, mg minus F sin theta. Okay. Put the value of Fk in this equation. We will get F cos theta minus mu k mg minus F sin theta equals to ma. Okay. Then the acceleration will be 1 by m F cos theta minus mu k. Let's take the F and F sin theta equal to F cos theta minus mu k plus mu k sin theta minus mu k m g equals to m a. Then what will be the acceleration? A will be one by m F cos theta plus mu k sin theta minus mu k g. This will be the acceleration part. F by m, let's change the value F by m, otherwise it will not give you the correct answer. Let's solve it. Simply F by m, this is the F. Okay, now let's remove it. Just solve it simply here. No need to do any extra step, just solve it from here. A will be simply F by m cos theta minus mu k, m will be cancelled out, then g will be left, F by m